not to push you too hard or anything.
You stay right there.
Yeah, I'm going to be close to my friend Andy here. Okay, well, thanks for coming. This is our second day of testing of the garage door concept. And the idea here is that a lot of buildings in San Francisco have so-called soft stories. They have big holes in the building caused by the garage door, and the garage door is sort of held off. It's not attached to the wall. It floats free. We're trying to figure out how can we make these San Francisco buildings a little bit safer. And the idea came to us that perhaps if we use the garage door itself as a shear resisting element, as a force resisting element, that maybe we can quickly and easily figure out a way to improve seismic safety. And well, gee, last time we were here, what was it, 4 weeks ago, we got pretty good values out of this thing. We pushed what we have here. Let me explain it, and then Andy can help talk about what we've done. What we have here is a San Francisco house front with a garage door. Get rid of now. The garage door. If you want to take a look from the other side, you can see we got siding, we got wood studs just like in your house. We got a foundation, and it's all built inside this big steel frame. And within the steel frame, we have a little hydraulic jack that pushes it back and forth. So we can see how much the building is going to rock back and forth in an earthquake, and then what the effect of the door is. So this is just a regular old off-the-shelf garage door. Art, the garage door man, is here, right? This is the kind you often install. No special upgrades. And so what we're going to do today is push this thing back and forth with nothing on the door, just like your normal door. So we have a baseline of how it's going to perform. And then we're going to do this interesting upgrade scheme. Last time we basically took a simple block, something like that, and we put it up against the garage door like that and screwed it to the frame so that as the frame moved, it pushed on the garage door. And we got loads of 4,000 pounds.
That's correct.
Vicious. Okay. We're going to do the same thing today. We made them out of steel this time instead of wooden blocks. And we're going to mount it on the outside, which was the idea of another garage door guy, Coco. Is Coco here yet? Coco's coming. Okay. And so we'll test it with these little pieces of steel channel that we made out of just a typical heavy-duty metal studs. And I put, as you can see, we'll talk in more detail, I put some non-skid tape on it so that it will resist the upload forces as we move it. So Andy's got some, everybody's volunteer here, except, of course, the city people who get paid to do it. Andy and Tom, who's over here, our instrumentation man, are volunteering from Scientific Construction Laboratories in East Bay.
Yes.
And they have set up all their normal testing equipment, and we've got a full monitor, and we're keeping the data and analyzing the data. You've got some stuff from our last test. Why don't you tell us what we got here?
Sure, Lawrence, and that was beautifully explained too. The concept going on here. But yeah, last time we were able to just plot out in yellow and orange what the unimproved door and frame was good for. And as the thing drifted out to 3 and 4 inches, in big round numbers, that was good for 2,000 pounds. But once we added the little improvised pieces of blocking and were able to really engage the door, this is what the green friendly line is, and it came out on a similar line until it got to about 1.5 inches, and then it really started getting strong. So even with our little experimental pieces of wood, by activating the door, we were able to double the capacity of the front elevation of this wall. It's very, very, very exciting. And so today, with more scientific pieces of metal with non-skid tape on it, we're hoping to recreate this and validate this system as a retrofit option. It'd be a tremendous increase to safety if it works.
And so today we're going to do 3 tests. We're going to do this baseline where we just push the wall back and forth and see how strong it is with nothing. Then we put this little upgrade system that we've designed on. Then we're also going to do a 3rd test, which is using a cable racing system where we're going to run the cable from one diagonal to the other diagonal. We're working on, not all houses have wooden garage doors, so we're working on another option where we use a cable brace system, and we'll talk more about that as we get along. The next step after today over at UC Berkeley's Richmond Field Station, we were going to build a real two-story house on the shake table. They have a shake table, 20 feet by 20 feet, concrete slab with hydraulic drivers that make this thing move back and forth in all directions. I don't think they even move vertically if you want to, I guess.
Correct.
And we're going to do a full dynamic test of the system, and we're going to look at other stuff as well, non-structural and other structural issues. But this will talk about validation. That'll give us one more opportunity to both improve the system and validate what we're trying to find. So, questions? Anybody have questions? You want to watch and push this door back and forth? Okay.
I think, just to
go ahead.
volunteer, maybe we should have Tom just explain the hydraulic system and then where we're taking measurements and
Okay, yeah, please.
just the mechanics of this test setup. And then we'll be able to watch on the monitor as the test progresses, and Tom will tell you where to look and what numbers will be important to take note of.
Okay.
So this is Tom Voss, principal over at Scientific Construction Labs.
So we have a hydraulic ram with a stroke of 10 inches. And it's a push-pull ram, so we can push out as well as pull back. And what we have hooked to it is a bracket at the top, and we've extended the ram out 4 inches. So what we're going to do is we're going to push 4 inches and then pull it back to where we started, and then 4 inches the other way. To measure displacement, we have a string pot, which is capable of doing 10 inches, so we have that extended 4 inches out, so we'll get the displacement on the full swing of the test. And to record load, we calibrate in our lab our hydraulic ram with 2 pressure transducers, one for push and one for pull. So 3 sensors, and the data will be on the screen.
And he cranks this with a little hand pump. Where's that little hand
There's two.
pump? There are 2 of them, okay, down on the floor there. And the data comes out on the screen, and we can stop and take a look at it as we're moving along today. Okay, that's very cool. And you guys can explain what we're looking at as we
Sure.
see it. Okay, I want to move this cable over to the other side, get it out of the way here. So let's just get a ladder up there. This is for later today. We don't need it in the way. Later test. Okay, so the first thing we do is push it back and forth. We're going to cycle it. I guess we're going to cycle it twice back and forth.
Yeah, initially we'll take it 4 inches to the right. We may hold it at that point and look at the frame just to see whether we can note any distress or damage. And then we'll bring it back to 0. And then we'll take it 4 inches in the opposite direction. And then bring it back to 0. And then just 1/3 last cycle, we'll take it to positive 4 inches again, bring it back to 0. And that'll be the completion of test number 1.
Okay. Very exciting.
Okay.
Watching paint dry.
Okay, so we've started the test. Right now there's about 400 pounds of load, and we're about 3/4 of an inch of deflection to the right. So we just went past 1 inch of deflection at 600 pounds. You can start hearing some creaking of the system. Now we're at 1.5 inches. That was 800 pounds.
Now the garage door is not engaged in any way. It's just held in place with its typical little metal clips at this time.
Now the frame has just gone past 2 inches, and that was at about 850 pounds of load.
Which is not a heck of a lot. Really.
No, it's not. I mean, it's
The pins will come off the back fixture,
Right,
and you wouldn't be able to open your door.
right. We put them back in when we reuse them. This is what would happen in an earthquake where the building deflected this much, which is quite a lot, but the garage door pins might fall out. The door is not really helping prevent it from moving.
right now. We just went past 3 inches, and that was 1,300 pounds. So that's 3.5, Tom. Oh, you can see it. Never mind. There we are. There we are. We just topped out at 4 inches, and it was about 1,800 pounds Now that's consistent with the test results we had last time for the unimproved frame, where the door more or less floats in front of the system and doesn't really help in any way.
Say 1,800 approximately. At 4 inches with no upgrades. This is with redwood siding and nails and 2x4 frame.
Okay, now the siding, is there sheathing on it?
No, no sheathing. We were looking
It's only,
at just
it's
redwoods,
only the,
horizontal board siding,
okay. I
and
mean, many San Francisco's would have diagonal sheathing under the older ones.
some of them would have.
And
different
newer
colors.
ones would have hold downs. We're not doing any of those. So
New
we're
ones would
taking
have what?
a hold down.
Hold now. Oh
I
yeah,
mean,
we're
yeah.
not doing new.
So we're doing things that are the old fashioned.
Old-fashioned way. We're talking about how can we upgrade old San Francisco style homes.
But, so all that distortion is happening in your boards
Right.
are going that way.
That's right.
Can we open the door when?
Well, we
when
can.
it's like it is now?
We tried last time to open it when the building's deflected and it's kind of jammed in its track.
Yeah,
So we can't.
Okay, so Tom, if you let the load off.
Okay. Now we'll go back the other way.
Last time, whenever we just took the load off.
Doing it by itself.
Okay.
And it came back quite well.
Well, it's still got 1.5 inches of bend in it.
That's 1.5 inches.
Correct. So Tom physically has to turn on the other pump and drag it back to 0. But it only takes 100, 200 pounds to drag it back the other way.
So that was the,
Pretty good. Well, usually a 3-to-1 ratio, that kind of low stuff.
the first shake of the earthquake. That was the first
Right.
shake, or first half of the first shake. Right, the first jolt.
But Seegers, you'll see from the boards back there, they actually snugged them down pretty tight. So any of the gaps that you traditionally put there for shrink swell aren't really there.
So normally in an old building, the boards shrink and they space themselves apart. But what we have here are new boards that are tight together, so it
Right.
actually has more strength than an old building might have in a similar condition. Also, the nails are tight, whereas in an old building, the nail holes, you know, they expand a little bit, and the nails are rusty and so on. Okay, now we're
Okay.
going the other way.
Okay, so now we've started loading it. We're going to go to -4 inches in the other direction. So Tom's in a hurry. We're already at almost -2 inches.
You're minus 2?
Yep.
It's a little, the header is a little distorted from the door, isn't it?
Okay.
Yeah.
Same offsets when I hit my garage with my car.
Okay. We just ticked over 1,000 pounds and we're at 3 inches. The left. We're gonna hit that break. Keep going. Okay. Currently we're at -4 inches.
You're minus
Yeah.
4.
Only took 1,400 pounds.
Okay, now,
It gets less and less.
Okay.
as it
It's
rattles
softening
back
up.
and forth.
what's that?
It gets less and less every
Yeah,
time it rattles back
and
and
we're
forth.
going to go back again and it's going to soften up even more, as in a
Put it in
typical.
for the observationists out there, you can see that some of these studs, where they're toe-nailed into the sill plate, they're pulling up. Some of, even like the felt behind the, is wrinkled.
It's a nice shape, you're getting picked with a TV, because it's a nice shape of the,
Yes, exactly.
stud. I mean,
Yeah.
you see the distortion.
Got some nice pier bending happening here.
Is this a new, you had a wall last time you tested?
This is the same wall we had last
So
time.
you
We
didn't do anything
rebuild the
to it?
wall. No.
You didn't
All we did
renail
was,
it?
we connected the header to the double top plate because the little cripples up here all kind of
Therefore,
got.
this thing's already been through 4 inches even before we
Right,
started this time.
right, that's
So you
right.
really could add this one if you're showing the blue.
Well, we have a few minor changes. We have this little connector up here and we put these little 4x or 6x blocks. Those are
Oh, you
used.
didn't have the blocks?
No, we didn't have the blocks. Those blocks are going to be used to attach our diagonal cables on our third
Those
test.
blocks make a big difference.
They do, but after we soften it up, I think it'll,
You see how they fix the, they fix the studs nicely.
yeah, they
But,
do.
Yeah, none of the siding was renailed or tuned up in any way before this round of testing. Okay,
You're
Tom,
getting a
so
lot of energy, a lot of good stuff out of
So-
that siding.
let it go, Chief.
Boom. So one of the things that was interesting in the Curie study recently, the Consortium of Universities for Research in Earthquake Engineering, right? They found through looking at work on wood frame buildings that it's not the specific elements that provide a lot of strength, but it's the composite of all the different elements, you know, the stucco and the lath and the sheathing and the drywall and the studs, and when you put them all together, you basically have a laminated assembly. You have a composite assembly, right?
Yeah, exactly. I mean, the entire assembly is got a lot more value than you can get out of just the elements added together.
Right. The whole is greater than the sum of its parts.
That's the secret of conventional framing.
Something like that. Yeah, right.
Okay, so Tom, we are back near zero. Very well. Now you guys will notice that we've been 4 inches one way or another. The little glass panels within the garage door fared pretty well. Most of the distortion was taken up by these tracks which float in front of the system. But last time when we brought the door into bearing by using little short blocks, in fact that's what these scribbly blue lines
Here,
were.
I can show you, here's a block. You want to hold a block up there?
Yeah, last time just, it was inspired. We were just trying to get some contact between the frame and the door. So wherever the scribbly blue lines were places where we had contact. So we can see here, again, just behind this hinge assembly. We thought that was important because, the joints between these doors are joined by fairly sturdy hinge hardware. And that's all capable of acting structurally if you allow it to. And again, we had a couple of blocks across the top. Today's tests, we won't have any connection at the top of the door. And we'll purely be trying to rack this thing as a parallelogram and see how we go. But again, keep an eye on the glass panels and some of the joinery here at the corners. Last time, as violent as these tests were, the most we ever saw was a little bit of gap opening here and a couple of staples sucking in. So very little distress.
Do those blocks hinder the opening and closing of the door at all? Are they actually touching the door when the door is
The
No.
way,
closed and true? Or?
Now, last time there was enough of a gap the door could operate smoothly. It was just merely as a quick way of testing or getting an extra bang for our buck during that testing day to prove a concept. So today we've come back with a more scientific version of the block.
Right.
Hopefully it'll work.
right. Okay, so we're back to the beginning. Okay, now we're going to just jack it back and forth one more time to see what
Just
the...
out to 4 inches one more time.
Rail,
Yeah, you can actually see the pin for the wheel here is pulling out of the hinge.
See, the doors really are designed to float free of the wall so that no matter what happens to the house, the door is not damaged or affected. I mean, that's the goal of putting in a garage door so that you don't, changes in the building don't affect the operation of the door. Of course, with our goal is to use the door as a shear wall so that after an earthquake, it may in fact no longer work, but at least it will have kept your house from collapsing, right?
That's not good from a business,
It's good for garage door business. You get to fix it, replace
have to
it.
replace it.
Yeah,
Because if it's-
there you go.
if it's that damaged, then they have nothing to say.
Oh yeah, right. we need a system that crunches them.
My brother's a foreman in Florida. Don't you think he loves it? Every time an airplane gets
Okay, so we're
Okay, we just ticked over 3 inches.
3 inches, 1,100 pounds.
this is about to lose it.
That's pretty far over, huh?
That's going to come out.
Yeah,
Pin on the top.
3.7.
Whole length of it.
There we are, 4 inches. It's about 1,700.
How much?
1,700 that time,
So it's softening up a little bit, but not
as
much.
opposed to 1,800 the previous cycle.
Okay,
Okay. So, yeah, you see how much this pin came in?
yeah. So this whole track just kind of moves and deflects.
Track went with it.
Yeah.
Okay, Tom, you can let it go.
Look at this. If the track was well, we talked about bracing the track, but the track is, yeah, that's right.
that would do something else. I went back, it went back further this time. Did it go back by itself?
Yeah,
Where's it
it's,
at now?
well, Tom's let the load off.
Yeah, when I pump this back to where we started.
Oh, okay, you just dragged it back to zero, Tom?
Yeah.
Yeah, we're back to zero.
We're not back with the rail. There's something, there's something a little distorted.
Something distorted here? The track, huh?
It looks like it's kind of, is there
Yeah.
just, that's why is there a joint up there where the
Yeah.
tank comes?
What's going on up there?
Well, okay, if we're at zero, no,
You
just
should be
operate
able to open
open
this.
the door.
These things are very resilient,
Very tall.
very resilient. Isn't that amazing how resilient they are? It's incredible. Well, even last time after we took the door and pushed on it 4,000 pounds, brought it back to zero, and the door operated perfectly. Pretty amazing.
All right, well, we're going to
Okay,
take a break.
we have one more cycle back that way. To,
Is that 2 complete cycles?
Do you want to do two? each
yeah,
way?
let's do the other half of it. Then at least we have a
Very well.
uniform. Maybe it'll bend our tracks all back. Yeah,
Put it back to where it was.
yeah. You see it all moving. The garage door is staying still, and the wall's moving behind it.
Tom's in a hurry. He's already gone past 3 inches. That's 1,000 pounds.
Loose now.
3
Yeah.
and a half. Coming up on 4 inches.
Pretty loose, yeah.
And that was, 1,500 pounds that
Okay.
time.
Okay. Back to zero. Back to zero. And now we're going to, as fast as we can, gear up for the trial where we actually put the stuff on. While we get ready, as soon as Tom gets us back to zero, I'll come back here and I'll show you exactly what we're going to do. Should be kind of interesting. What's that? Okay? Okay. Why don't you come here? Come on back here and I'll show you what's going on here. What we're doing.
You want us to drag
Oh, we didn't
light back
change
with
the,
you? Do you have a light on that
yeah.
bad boy?
You get a little light pointed this way, that'd be helpful.
Okay, let me get it.
We didn't change the stop, but I suppose it's okay. Come on back here. I got to show you what's happening here. You're in the front of the house now. See, here's the siding. Here's the studs and the nails. Here's the garage door. Now, what we're going to do this time is we're basically going to screw this. We're going to close the door. Like this. And we're going to screw this piece of metal onto each one of these segments, so into the door, so that as the wall moves, it pushes against this, which pushes against the door, and basically pushes diagonally compression strut to the foundation on the other side. So each one of these little pieces has a piece of metal screwed onto it. And that's all it is. And then when the door goes up, metal passes by the
I
right.
don't think you can have that on the top section. Huh?
The top section, I have to cut it at an angle like this.
Okay.
Just so that it clears, and I'm ready to do that as soon as we measure it. We'll do that right now. So it'll take me about 20 minutes to screw all these things on there, and you can help if you want. Okay, everybody, got it? Okay. Whoa! It's a sunny day.
Is this a raid?
Okay. Now, Kirk, my friend, I've got the top ones we're going to have to cut. No, we're not going to drill them. We're just going to screw right through. I got my self-tapping. Do you guys have? Yeah, I have self-tapping screws. Do you guys have a drill? Yep. Drill. Let's get 2 of them working here.
Yeah, let me just get the Phillips bit onto that.
Here's the. I was going to use these 1-inch guys. Put like 5 or 6 of them in.
Perfect, yeah.
Okay, and I've got a bunch of boxes of them. I want to put one in just so I can see, and then you can take over. Don't put the top ones until I cut them, okay? Okay. Bring them back this way here, Kurt. Come on back on the inside.
Okay.
Here comes the big. Anybody else coming? Come on in. Gotta close the door. So, any one of these. Now, the only problem we want to do is make sure that this is a bottom track, give me a middle one. We have to space them so that they don't grind against the door.
Correct.
Should we use a piece of cardboard or something? What do you think?
Yeah, no, I was seeing a credit card or a...
Credit card. Now you're talking. Okay, who's got a credit card?
My Kaiser card.
Okay, somebody hold it in there and I'll... Safeway card. Here, I get that. I want the credit card. Somebody hold the credit card in. Yeah, that's all right. Use the credit card. There we go.
We don't want to span the gaps on the door or anything.
No,
We can't, that's what I said.
that's not gonna work here. This stuff that's in there. Yeah. There we go.
Look at that.
Credit card's in for good now.
There we go. Okay.
We'll sort of leave it in there just in case you snug them up.
Okay. So that's what we're doing. Let's do it as fast as we can. In the meantime, I will. So we're going to put one in the bottom, one in the top, and two in the middle. We'll put 5 on each. Yes, that's about right. There you go. Kirk, why don't you do that, and I'm going to get the tops cut.
Need a handful of screws. Thank you.
Lawrence, why do you need the sandpaper side the way you have it?
Ah, good question. There's a problem. There's an uplift component as this thing is going. It's tipping, and I'm trying to increase the friction against the side so it reduces uplift. And so I think that sandpaper will really. It's actually the non-skid tape for steps. Very, very sticky stuff. And
I handle something.
it's really something, isn't it? So I think that will effectively prevent that uplift.
So the key is not to have the garage door askew so you
No,
grind the
that's
paint
the
off
soft
the side as the person uses the garage.
Say it again?
You don't want them to lose their paint job if they skew their garage door over time.
Well, it's going, yeah, we have to deal with the fact that this is going to grind the paint off that piece of trim, and I'm not sure quite yet how to take care of that. But
Maybe you need to figure out how much of a distance is a credit card size
Yeah.
greater.
right. So we're just starting. Well, we want it to be as close as we possibly can.
Okay.
I have to, as soon as you guys.
Good.
Okay, I want to lift the door up whenever you guys are ready, just so I
Maybe we
can
should start at
measure
one end
something.
rather than in the middle.
Yeah.
Otherwise, no, leave that one. Leave that one. Pull that one. Pull this side. Otherwise, we use the center as a pivot.
Whenever you got, can I lift it just for a sec?
Sure.
Okay.
Yeah,
Okay.
I've got one that's in contact over here.
3/4. Okay. I'm just going to cut this thing so it works. 3/4. Okay, and we're going to put 5 screws in each one, guys. What's that? Really? Okay, we're almost there. It's actually going, whoops, very fast here.
Yeah, you're right. Plus if I,
Got some noise. I gotta make a little noise here. Yes, that's what it is. It's what I've used to cut these things. Excuse me. Now,
I'm swiping the Safeway card. Yeah. Now, a handful of screws and another.
How many clips we got? The last one?
He's got a bunch out there. So I'm not sure what he's doing.
Easy for a homeowner.
Just cut them up.
So they can engineer it.
Or way below. One here or way
Well, what are you looking for? Yeah, there's over on the workbench. I have the 2 top ones here.
You guys got more screws in?
There's 1 more on the workbench, 2 more on the workbench. Yeah, something. The bottoms are longer. They're 18 inches.
Oh, okay.
Right.
Tell me what, okay. Okay, right here.
Going backwards.
They are. They don't have the side pieces. They are. No, I can't afford one of those fancy alarms.
You don't need me, you just need that plastic.
If I do it this way.
That's really the most important one right here.
Good job.
Okay, here's a theoretical piece we can try. Okay, hang on one sec, guys. Oh, look at that. Oh, well, perfect. Okay. Need our spacer and put that thing in there.
Lawrence, the top and bottom ones probably should have an extra screw or two in them, maybe screw the
Okay. And they're longer too, yeah. I have an extra battery for that.
That's okay, that's fine. You can play this, don't worry about it. Too much space.
Should be as tight as it can get without binding. Actually, it can be pretty tight. Why don't we make it tight up there? Because it's going to leave it just the first second. Perfect.
Top piece.
Oh, these doors are strong.
You have enough pieces there? You missing a piece? You missing a piece?
There's one behind your foot, behind that.
Oh, good, okay. Oh, there's one on the bottom here.
I think we're one short.
Okay, it must be out there someplace. One more piece lying around here someplace. It's got to be around there because I made the right number.
Getting there. Beats my day job.
Here it is. Nope, that's not it. That's a different. Yeah. Yeah, I was holding one and pointing with it. Maybe.
Wow, good job, good job.
Perfect.
You would need all 5.
What's that?
Oh, we have forms like that.
No. No, but they're interested. They called me and said, when are we ready to roll it out? I'm gonna let them know. And, I will. I said, yeah, great. Oh well. Yeah, it would be nice. They're busy. They got emergencies planned for. Yeah, actually. Okay, so we're almost ready.
You got an extra, you got 5, 1.
That's fine.
So the numbers of nails on this side are what the number of nails on this side.
Watching what? Oh, yeah. Right. Yeah, it is. This is great. Thank you so much for getting involved. Oh, you know, we got to tighten these things up. Here's a little crescent. There are some that are just completely loose, like somewhere in the middle. This one was. I don't know quite why.
Being a testing guy,
Actually, it's not uniform.
Oh, very small.
All done. All done.
There's not many people that you come out in the field and do this pushing and instrumentation.
We're stuck here now.
No, you push it down.
Good. We had a couple of loose panels. Tight. Yeah, they're almost done. As soon as they're on, I'm going to open it. You guys can take a look and then push it. Only take a few minutes. Like, oh yeah, look at that. Probably from the last time we did it. Huh?
I think
You can make it here. Maybe down on the bottom. Reinforcing.
Right, easily done, right? Just slide them in there. And,
Slide them in there, washer on each end.
yeah. If it turns out it's a point of failure. So. Why don't we look close? Yeah,
All the way down.
right.
well on this side.
I'm hoping that people actually get garage door installers to do this, because then they can tighten up all the hardware, they can lubricate the stuff, they can make it, probably make it work a whole lot more smoothly than, you know. Do you want to try that before you screw it all the way on? Yeah, there you go.
We'll make it work.
That's a tight fit.
It's much easier now that the holes are already punched through the metal.
Yeah.
Yeah, I mean, if you had these things with pre-drilled holes in them,
Yeah, oh, this is okay. This is okay.
Because you need some space.
Right. Okay. at that.
Nice.
Clears. It actually works. So anybody want to look at it before we test it? Go ahead in there and we'll drop the door and you can see what we did. If you weigh less than 100 pounds, you can squeeze through the crack there. Okay, so we're back to 0 here, I think. Is that where we are?
Yeah.
Okay, this is the big test. This is the real thing.
Well, you have to break it down.
So the first thing that we expect to happen, of course, right, is the glass is all going to pop and shatter, and then the doors are going to start falling apart. But it didn't happen that way last time. It didn't happen at all. Yes?
You have 4 inches of displacement.
Yes, same thing. Tight to the door, 4 inches. Okay, I'm ready whenever you are. Okay. Displacement. We're going backwards, right? We're starting. Displacement at the top, 0.3, okay. 0.3. 400 pounds. So the last time it actually took us a while till we engaged the door. It took us an inch or two, an inch before we engaged the door. 500 pounds, displacement at the top. Inch and a half at 1,000 pounds. Oops. The sound has changed. Something's changed. The noise has changed. 2 inches at 1,100 pounds. Two and a half for 13.